Let's look at Venn diagrams. So Venn diagrams are useful in seeing the relationship between the items in two or more different sets. So we've got 6 Venn diagrams here. Within each Venn diagram, we've got 2 circles, where the first circle here represents set A and the second circle here represents set B. And that's 2 different sets that are formed to make one Venn diagram. The rectangle is used so that we can include any items or members that are in neither set A or set B. If we wanted to shade in set A, then we would need to look at the circle that represents set A, and everything inside that circle is within that set. We would have everything within this region as well as everything within this middle region as well. So all of this in total represents set A. If we wanted to represent set B, then we would shade in everything inside the circle for B. So that's this middle bit here as well as this bit here. And that would represent everything in set B. So adding on the set notation, we have set A, which is represented by this Venn diagram above, and we also have set B, which is represented by this Venn diagram above. Now, suppose we wanted to work out A union B, and we wanted to represent that on a Venn diagram by shading in the Venn diagram. Then, if we remember, A union B is everything that's inside set A and everything that's inside set B and everything that is in both sets. In other words, we would need to combine both of these Venn diagrams together, and everything that's shaded would represent A union B. Everything inside circle A, so that's all of this region, and everything that's inside circle B, so that's the middle region and this region here. And everything that's shaded inside this Venn diagram now represents A union B. Likewise, if we wanted to work out A intersect B, then we would need to look at the parts of the Venn diagrams which overlap in both A and in B. In other words, any region that is shaded in A and it's also shaded in B. And if we look closely, that region is the middle bit here. So this middle bit is shaded in this Venn diagram. It's also shaded in this Venn diagram. And so therefore, if we wanted to work out A intersect B, then we would shade in that middle region that's common in both A and B. We can also use Venn diagrams to represent sets that involve complement. So for instance, if we wanted to work out what A complement looks like on a Venn diagram, we would shade in everything that is not in A. So if this circle is represented by A, then we need to shade in everything outside of that to get A complement. And so that would be all of the region outside here, as well as some of circle B. So this bit here within circle B would also be shaded. The middle region here would not be shaded since that's involved in A, and we are only looking at A complement. Likewise, we could work out B complement, and so we need to shade in everything that's not in B. If circle B is here, then we need to shade in everything outside, and so that's this region within A and also the region outside both circles. And so this would represent B complement. Now, like we did previously for A union B, we could also work out A complement union B complement. We combine both of these Venn diagrams together and we're left with A complement union B complement. So that would be everything on the outside as well as everything that's inside A apart from this middle bit which is not shaded, and everything that's inside B apart from the middle bit that's not shaded. So A complement and B complement, the union of the two is given by this Venn diagram here. We see that all of this red region is shaded and is represented by some of the green regions in this Venn diagram, and we also see that all of this blue region is represented by some of the green regions that's shaded in this Venn diagram, and that both A complement and B complement don't have the middle bit shaded, and so that middle bit here is also not shaded in A complement union B complement. We could also have any combination of A, B, A complement and B complement with union and intersection when shading in Venn diagrams. So for instance, if we look at A intersect B complement, then we need to look at all of the regions that are common in both A and B complement. So looking at A, we see that this whole circle is shaded, and so within B complement, we need to look at that circle and see which parts are also shaded in B complement. So just looking at A in B complement, we see that the part that's also shaded in B complement is this region here. And so for A intersect B complement, we would just have that region shaded there. So just A, which doesn't include any of B. And this would be A intersect B complement. Likewise, we could have A complement union B. And so for A complement union B, the method for union is we look at A complement, we look at B, we combine the two Venn diagrams, and everything that's shaded is shaded within A complement union B. So first, if we start off by shading an A complement in our diagram, we have everything on the outside of the two circles, as well as everything that's shaded within this region. And then we now also need to shade in B. So B is that whole circle. We've already shaded this part within our Venn diagram, and so we now finally need to shade in the intersection, the middle bit here. So shading in that middle bit there, we end up with A complement union B.